Good mornings. We need to find the complete integral of these two differential equations, and we are going to use here the standard form 3, which is of the format fxp is equal to gyq, and the equation is of the form this kind. As we can write this equation as, for this format, it is p square minus x equal to y minus q square. So the function is involving x and p on the left hand side and y and q on the right hand side. Right, now how to solve this standard form 3? First we are going to discuss the steps. For the standard form third, the partial differential is of the form fxp equal to gyq. When you get this kind of format, just take this to be equal to small a, where a is the arbitrary constant. And then you need to get the values of p and q, and then in the third step we have to use this equation and then integrate this equation to get the complete integral. Now the first part is we need to solve p square plus q square equal to x plus y. First we need to get this format. So having p square minus x on the left hand side and y minus q square on the right hand side. Taking this equal to a, and we need to get the values of p and q. If p square minus x is equal to a, when taking these two, we get p square equal to x plus a, and from here we get p equal to the square root of x plus a. Similarly, we can get from these two, when taking y minus q square equal to a, we get q square to be equal to y minus a and q equal to square root of y minus a being constant, the arbitrary constant. Third step is to use dz equal to p dx plus q dy, and now putting the values of p and q over here from this. On integrating we get z to be equal to, it's x plus a to the power 1/2, so when integrating it becomes plus 1, that is 3 by 2 divided by 3 and here 2, plus it's y minus a the power 3 by 2 and multiplied with 2 by 3 plus the constant b, where a and b are arbitrary constants. So this is a required complete integral. It is the required complete integral. Moving on to the second part. P square plus q square equal to x plus y into z. Now the extra z is involving over here. What to do now? We need to get the format as fxp equals to gyq, and there is no z. We don't need this z. So let's first manage this equation in another form. Let's divide this equation with z. Right? We can write this as p divided by square root of z whole square. Can we write like this? Of course. It is q divided by root z square equal to x plus y. We are going to substitute w to be equal to the square root z, but I am going to substitute this w to be equal to 2 square root z to get the easier solution, right? And for p and q, I know that the small p is del z by del x, which can be further by chain rule. We can write this as del z by del w into del w by del x. The partial derivative of z with respect to w into the partial derivative of w with respect to x. From here we have w to be equal to 2 root z. From here we have squaring both the sides, and then z is equal to w square divided by 4, and now we can find del z by del w, and that will be equal to 2w divided by 4, that is w by 2. So del z by del w is w divided by 2 into, we cannot find this, so let me substitute this to be as capital P, and putting w to be equal to twice square root z divided by 2 into p, so it is small p is equal to square root z into capital P. Similarly, we can also find small q to be equal to square root z into capital Q, where this capital P is del w by del x. Similarly, when you find your q, that will be del z by del y. Z is depending upon both x and y, right? So which can be further written as del z by del w into del w by del y. Again, what is del z by del w? We have found this to be equal to w by 2 or 2 root z by 2. So that is root z only. And we take this to be as capital Q. So we are taking capital Q to be del w by del y. It is important to mention. So when putting back these details of P and Q in this original equation, let me mark this as star. So from star we get small p by root z whole square plus small q by root z whole square to be equal to x plus y. And further, small p is square root z into capital P divided by square root z whole square plus small q is square root z capital Q divided by square root z and whole square equal to x plus y. So these cancelled out, and finally we are having the equation of the format, the third standard form, that is fpx equal to gqy. So changing to this format, we have p square minus x to be equal to y minus q square, and taking all these equal to small a, where a is a constant. So when p square minus x is equal to a, we get p square to be equal to x plus a, and capital P is square root of x plus a. Similarly, capital Q is the square root of y minus a. Dz to be equal to capital P dx plus capital Q dy. So putting these values over here, so from here we get z to be equal to x plus a the power 3 by 2 multiplying with 2 by 3 plus y minus a the power 3 by 2 multiplied with 2 divided by 3 plus the constant of integration. Okay, this is when integrating, right? On integrating we are getting this. B being the constant of integration. So where a and b are arbitrary constants. So this value of z, this is the required complete integral. Alright, thank you. Stay blessed.